Hello again, and welcome to Astronomy Toronto, produced by the Toronto Centre of the Royal Astronomical Society of Canada. My name is Randy Attwood, and I am your host. Astronomy Toronto is a monthly astronomical news magazine where we discuss astronomical and space happenings and talk to people who are involved in both professional and amateur aspects of astronomy here in Toronto. Today my guest is Ian McGregor of the McLaughlin Planetarium, and we will be talking about what's happening in the skies this summer. Hello, Ian. Welcome to Astronomy Toronto.
Hi, Randy. Glad to be with you.
To start off, Ian, you're the president of the Toronto Centre of the Royal Astronomical Society. Could you tell us a bit about this organization?
Well, the Society is an organization of amateur and professional astronomers that are spread across Canada. There's about 3,000 members in the Society overall. The Toronto Centre is one of 19 clubs or centres which are in the Society. And the Toronto Centre is the largest. We have about 700 members. And our base of operations is at the McLaughlin Planetarium.
And there are several activities that go on for the members.
There are a variety of different things. We have meetings, usually 2 meetings a month. There's an observers group. We have an observatory. There's a telescope makers group. We organize star parties at different forums. We also have a variety of publications as well that we put out and distribute to members, and I brought some along.
Okay, well, maybe we could look at those.
Sure, we can have a look perhaps at these publications. There's 4 basic publications that are put out by the Society. First of all, one of the most well-known is the Observers Handbook, which comes out on an annual basis. There's something like about 15,000 of these that are distributed annually, and it's basically a guidebook to the sky and what is happening, month-by-month charts of where the planets are, constellations, things like that. Society also has a journal, and this contains articles by professional astronomers and amateur astronomers and a very well put together publication. We also have a national newsletter, and the national newsletter is put together containing articles, material by amateur astronomers, and it sort of talks about astronomy in Canada and what people are doing, conventions that are going on, special meetings, observing techniques, various things like that. And then the Toronto Centre has its own newsletter, which comes out every 2 months. And this is Scope, and our host here is the editor of Scope, and this is an excellent publication that comes out every 2 months.
So the national newsletter goes to all 3,000 members of the Royal Astronomical Society of Canada across the country, while Scope goes to our membership.
Scope goes to our membership, the 700 members of the Toronto Centre.
Members. Well, behind us, as you can see, we have a banner here. Maybe you could tell us a bit about our banner.
This is a banner that we put together just before our last solar eclipse expedition, and it was actually made up in honor of our solar eclipse expeditions that we've had. There are 4 expeditions that are listed on this, ones that we've had in 1972, 1973, 1979 to Manitoba, and also 1980 when we went to Kenya in order to see a total of eclipse.
Total solar eclipse.
Total solar eclipse. Yes, this is depicting a total eclipse of the sun that we can see in the center there. And we're hoping that in 1983 we're going to be adding another title on there, probably Indonesia,
right.
1983.
Well, there's certainly a lot more room there, and hope we can fill it up within the next 10 or 20 years.
I hope so. There's a lot more eclipses coming up. Maybe Hawaii 1991 or something like that, Mexico City. Well, we'll see what happens.
That's right. You're also a producer at the McLaughlin Planetarium, Ian. What's going on there this summer?
Well, sometimes when people go by the planetarium, they think it's closed, and it's very easy to think that. It seems to be a massive construction yard in front of the planetarium. But the planetarium is open. We do have shows that are going on. And our current summer show is a show called The Cosmic Puzzle. And it's a series of short sections talking about different aspects of astronomy. For example, theories that meteors cause the destruction of the dinosaurs, various different cosmic mysteries, black holes, for example, radio astronomy, the discovery of the galaxies, the missions to planets, and some of the discoveries that we've made about different planets, search for other planets that are in the solar system.
And there's a phone number that people can phone if they're interested. Is that right?
To get information about our planetarium shows, the listeners could phone 978-8550.
There is quite a bit of construction going on outside the planetarium, and you must remember that the planetarium is open, and I guess that number again is 978-8550 for any information on any of the shows going on at the planetarium this summer. There's also a large observatory just north of Toronto that Torontonians can visit, isn't there?
The largest observatory in Canada is the David Dunlap Observatory, which is located in Richmond Hill, about 15 miles north of downtown Toronto.
Well, we have a slide of that. Maybe we can
Yeah, I think we have
put
a slide
that
of
up
that.
as we talk about the DDO, which we might accidentally call it. But it's
We
the
might
David,
call that. It's the David Dunlap Observatory.
Right.
It was constructed in 1935, and the major instrument in it is located in the dome is a 74-inch telescope. Now, this isn't like 74 inches like this, big, small thing. The mirror is 74 inches in diameter, and it's an enormous telescope.
And there it is.
And there we have a picture of it, and we can see that the dome of it is open, and inside there we have this very large telescope. And this is used for observing stars and studying the light from stars as far as determining what the stars are like.
Well, if someone's interested in going to that, what should they do?
Well, they can phone up the observatory and visit it on a Saturday night. Throughout the spring, summer, and into the autumn, the observatory has special visiting hours. And by calling a number, 8842-112, and making a reservation during the week, they can say, well, I'd like to come up and visit this Saturday, and their name will be marked down. And they can go up and get a tour of the observatory building, a short talk. And if the sky happens to be clear that night, they can have a look at whatever an object happens to be in the sky, maybe a globular star cluster or planet or galaxy, some interesting object that's in the sky.
Well, there are certainly a lot of planets in the sky this time of year. Maybe you could tell us a bit about those.
In our current evening sky, we've got 3 planets, and they're all located over in the western sky. The most noticeable planets, of course, have been Jupiter and Saturn. And Jupiter, these 2 planets have been in the sky now for, I guess, well, in the early evening sky, I guess since before last Christmas. And as the months have been passing, they've gradually been moving further and further over towards the west. If we go out and look into the western sky right now, this evening, and a little bit up from the sky, there's 2 star-like objects that appear relatively close together.
Well, we have a slide of what these 2 stars, well, they do look like stars.
They do look like stars, that's
We
right.
have a slide with us today that was taken a few months ago of what this looked like. Just 2 stars in the sky. There they are. The one on the right is Jupiter, is that right?
The bright one is Jupiter. In fact, Jupiter is currently the brightest star-like object that's in the evening sky. And then off to the left of it is Saturn, which is appreciably fainter. These 2 planets have been sort of dominating our sky for many, many months now. And actually, now that we're into the summer's rolling along, and actually we're into only about our last month or so that we're going to be able to see it before it disappears.
How often do they get that close?
Not that often. We've been experiencing over the last 7 months or so what is known as a triple conjunction of these 2 planets. Now, a conjunction is when 2 objects in the sky appear close together. And in the case of these 2 planets, they were in conjunction last January, and again in February, and again on the end of this month, July 30th. They're in conjunction.
Well, that doesn't mean that they could collide, does it?
Oh, there's no chance of that at all. They're separated by millions and millions of kilometers.
I think we have the next slide that we have is a close-up of Jupiter. Well, this is a pretty good picture. It's taken by an amateur, isn't that right?
There's a photograph of Jupiter that was taken by an amateur in Ottawa, in fact, and it shows some of the detail that you can see through a telescope of Jupiter. One of the things we can spot on there's some bands that seem to be going across the face of Jupiter itself, and we can possibly pick out maybe a spot that's on there as well, which is known as the Great Red Spot. Sometimes when we look at Jupiter as well, we can also see some of Jupiter's 4 largest moons, what are known as the Galilean moons. They can even be seen in a pair of binoculars.
The next slide is also taken by an amateur in Ottawa, and it's a picture of Saturn.
Saturn is a very beautiful planet, and as seen in a telescope, and its most spectacular feature is its ring. It's its great glory. And I don't know anybody who's ever looked at Saturn through a telescope and not been impressed by this very beautiful ring system that it has.
Well, Saturn's been in the news recently with the close flyby of the unmanned Voyager spacecraft last November. It sent back thousands of amazing photographs and told us so much about Saturn and its moons, which were so new and surprising. And the next series of slides we have will maybe take a look at some of those pictures that were sent back from Saturn.
Excellent pictures.
Because, this is the Voyager spacecraft. Maybe Ian, you could tell us a bit about it.
Well, the Voyager spacecraft, there's actually a pair of them. And the most dominant thing that we see in the picture is the actual antenna, which is being used to send back signals to the Earth. The pair of Voyager spacecraft were sent out from the Earth a number of years ago. They both have traveled by the planet Jupiter, and successfully survived their missions to there. Voyager 1 reached Saturn last November, and I'm sure many listeners saw some of the spectacular pictures that were sent back by this spacecraft.
Well, let's take a look at those. Maybe see the next slide.
Let's have a look at a couple of them. There's one of the pictures there. That's a very good close-up. It's a better quality picture than you can get with any Earth-based telescope. We can see the rings. We can see perhaps a shadow of the rings on the face of Saturn itself. We might notice that even though we're so close to Saturn, the bands are not that noticeable.
Mm-hmm.
And when we call looking at pictures of Jupiter, the bands and the features on the face of Jupiter are very noticeable. But with Saturn, they're not.
The next slide will give us a closer view of the rings, actually a sight never seen before because the spacecraft had passed by Saturn and was looking back down from the other side.
The rings are very spectacular. Saturn's, again, great glory. It's interesting when you think about it. I often think about when I've talked about Saturn, say, before last November. I'd always come along and say, well, Saturn's got 3 rings around it. But all of a sudden, with the Voyager 1 spacecraft going by, we really can't quite say there's 3 rings around the planet.
Certainly aren't.
We have to say that there's hundreds or maybe even thousands of ringlets that we could say that describe it. Again, the rings are almost like a phonograph disc. It's all there, the rings that are around them. But those rings, of course, are not solid. They're made up of millions and millions of particles of ice, which are all moving in orbits around Jupiter itself.
Before the Voyager spacecraft made it to Saturn, everyone thought there was about 12 satellites. But the next satellite, the next slide that we have shows one of the satellites called Dione, which is an icy world. But the Voyager spacecraft discovered several satellites, didn't it?
Oh, we've added quite a few more to it. Remember, there's been a tremendous amount of confusion about how many satellites Saturn actually has. Before this mission, there were about 12. The unofficial sort of numbering system goes up to something like S32, but some of those satellites are actually
so there aren't really,
they're recorded.
There aren't 32 satellites.
There appears of 15 that we recognize right now. And at the end of August, when the Voyager 2 spacecraft reaches Saturn, one of its primary missions is going to be to look for more moons. And we have every reason to believe that we're going to find a lot more moons. It appears that one of the reasons why there are so many different rings around Saturn could be because there's a lot of small moons,
mm-hmm.
not big ones, but little tiny ones, that kind of shepherd the ring particles
mm-hmm.
so that they sort of stay in certain distances away from Saturn itself.
Well, this slide here is of a satellite that we knew about before.
This is one we've known about for quite a long time, I guess several hundred years, I would suppose, maybe 200 years or so, Dione. One of the things we notice about Dione is it's got lots of craters on it. Those circular features are craters, and craters are mostly in the solar system are caused by collisions
mm-hmm.
where rocks or things from space have come in, collided with the moon or the object, and there's a big explosion, and then we have a crater left behind.
It's really spectacular to see all those moons, which we'd never just seen as points of light for hundreds and hundreds of years, and now we see them as worlds.
Yeah, they're suddenly all individual. They're not just simply points of light, 15, 20, 30 points of light. All of a sudden, when you come along and say Dione, or we say Titan, or we say Rhea, there's a picture that can come to mind, and each one of them is individual. Its color, its features, its chemical composition, they're individual worlds.
Well, you mentioned that there was another planet in the sky. Maybe you just tell us about that.
Jupiter and Saturn are the 2 planets that are dominating the western sky right now, but there's another planet very close to the western horizon that we can see, and this is the planet Venus. Venus is currently acting as or will be a little bit later on, actually, in the autumn, as a sort of an evening star, shall we say. Venus is sometimes called the morning star, the evening star. Around the time that it's at its brightest, it can be after the moon, it can be the brightest object that we see in the nighttime sky.
So when would anyone be able to see Venus, say, this month?
Well, during the course of this month, and actually over the course of the next couple of months, you should look towards the western horizon, just a little bit, not too far away perhaps from where the sun is setting, and look for a very bright object. Still be kind of lost in the twilight.
So this will be about an
area.
hour after sunset?
Oh, an hour. Yeah,
just when it's getting dark.
Just when it's getting dark. You look for a bright object. The Venus is really going to come into its own next December.
Mm-hmm.
It's very abruptly going to increase in brightness and move into a much darker part of the sky. and I believe it's about December 16th that it's going to be at its brightest. And it's going to be a magnificent object in the western sky.
Well, apart from the planets, there are a lot of other stars in the sky that we can see, a lot of other things going on. Maybe we could just talk about some of the stars that we'll be able to see this summer.
Some of the summer sky. Well, the summer sky is a very nice time to look at the stars. I think one of the nice things about the summer, of course, is that although, say, in June and July, the day tends to be kind of long, still the nights are generally comfortable, and it's nice to go out observing. You can spend a couple of hours outside looking at the stars and spotting stars and constellations, and if you have a telescope or binoculars, kind of scanning the sky. And we might perhaps have a look at maybe some of the star groups. One of the most well-known star groups is one known as the not the Northern Cross, the Summer Triangle.
Right.
And we have a diagram that shows 3 of the constellations that make up the Summer Triangle. In the upper left, we have Cygnus the Swan. In the upper right, we have Lyra the Harp. And at the bottom, we have Aquila the Eagle.
Well, excuse me, when would they have first made these constellations? I mean, there really there aren't animals in the sky, but this was made up a long, long time ago.
Long time ago, probably, well, something in the order of maybe a few thousand years ago, but not that far back. The constellations that we recognize today, there's 88 constellations recognized today, don't really, some of them go back maybe about 1,000 years, well, sorry, about 2,000 years. A lot of the ones that are in the sky are relatively recent creations in the last maybe 200 years or so. These constellations are relatively old ones. The brightest stars in each one of these constellations, if we just kind of eliminate everything else, instead of the 3 brightest, would form a big triangle in the sky. And during the summertime, this triangle is almost directly overhead and is a very spectacular sight to see. We could these constellations are basically in the Milky Way, which is stretching across the sky. And if we go down towards the south, and looking towards the south, we can see another group of constellations. And these are the constellations of, some of them are zodiacal constellations that we associate with the summer season. Constellations like Sagittarius and Scorpius.
Well, we have a slide of this, don't we?
Yeah, we have a slide of this as well, which should show a diagram. And there it is right there. Sagittarius itself is supposed to be the archer, although for many amateur astronomers, and amateurs, when they often see Sagittarius, refer to it as the teapot. Yeah, it looks a little bit like a teapot.
All right. And the Scorpio certainly does look like a scorpion with its tail.
Scorpion looks like, with its tail, and the very bright red star known as Antares. Now, Antares means rival of Mars, and it's often considered to be the red heart of the Scorpion. And it's a very nice red star to look at in the southern part of the sky.
Well, if we could switch to the next slide, I think we have a beautiful shot of what the Milky Way looks like. Ah, yes, there it is. A beautiful picture of the Milky Way, if you can get away from the Toronto lights.
Oh, Toronto lights are a real problem looking at the Milky Way. And if we can get out in the countryside to a cottage, away into the countryside, we can see this great band of light that's arching across the sky. There are, as well, different kinds of star maps that we can use to identify some of these constellations in the sky that I've mentioned and other ones.
Right. It would be nice to have, for the people out there, to have their own map in their hands rather than to just memorize what we have on the screen.
Oh, it's impossible to memorize what's on the screen. You should have some kind of a star map that you can use yourself. And we can perhaps have a look at a star map that I brought with me, which depicts these different star maps. This is one that appears in one of the local Toronto newspapers, the Globe and Mail, and you can see it you can pick this up in the first Saturday of each month. And this it has a star chart, and it explains shows what different constellations and stars are of the current evening. It has the positions of Jupiter and Saturn and Venus on it, and down at the bottom it has further information on the stars and some interesting information. It has actually some information on the lunar eclipse in here as well, and some information on the brightness of stars. And this comes out every month, first Saturday every month, in Saturday's Globe and Mail. And it's a very useful thing. It comes from the Museum of Science and Technology in Ottawa. They're the ones that put this together.
Well, we're talking about the dark sky. I'm sure a lot of people who have been under a dark starry sky might have seen once or twice a meteor crossing the sky. And summer is always a great time for meteors. Maybe we could talk a bit about that. I know you've brought a meteorite.
Brought a meteorite along with me.
And we'd love to see that. But maybe you could explain what a meteor and a meteorite, the difference between them and what they are.
All right. Well, a meteor is sometimes called a shooting star. That's perhaps the common term people use for it. Sometimes a falling star. and you look up into the sky, and there's all the stars up there, and the Milky Way going across the sky. And then all of a sudden there's a flash of light. It lasts maybe a couple of seconds, maybe 2-3 seconds, and then it's gone. And you don't see anything for a little while, and maybe a couple of minutes later you might see another meteor going across the sky. And these meteors are basically little chunks of rock, which are about the size of your fingernail. And they're, although we generally consider space to be empty, there's little bits of rock and dust and things like that out there. And this dust or rock comes in, hits the Earth's atmosphere, moving very, very fast. And just as if we take our hands and we kind of rub them together very quickly, we build up heat. When that meteor hits the Earth's atmosphere, all of a sudden we have a lot of friction, the heat builds up, and a piece of rock burns up. And since most of it's only very tiny, about the size of our fingernail again, it burns up above our heads, maybe 100, 150 kilometers above our head.
And they're certainly traveling very fast, which would explain that they vaporize. They just don't exist.
They just vaporize. They don't reach it down to the Earth's surface. Now, occasionally when we look at the sky, we might spot an extremely bright meteor, what we call a bolide, bolide or fireball. And usually it's fairly big, and it's so bright because it's been able to penetrate down to the lower levels of the Earth's atmosphere. And it's often, this is where we sometimes get meteorites from. Now, I have a sample of a meteorite with me, and
you probably can't tell from the screen, but that is a heavy piece of rock.
It is a heavy piece of rock. This is actually, the mass of this particular meteorite is something like about 1,700 grams. This particular meteorite was one that's from Texas. It's from a crater that was found down there.
Maybe we can get a close-up of that if you hold it
Sure,
still.
we can have a close-up, okay.
And it's from Texas, you say?
It's from Texas. It's from what's known as the Odessa meteor crater that's located down there. And this is a piece basically of iron and nickel. This is why it's so massive. It's not light by any means. You want to hold that and see what it's like?
This didn't fall on anybody, did it?
No, it didn't fall on anybody that we know of. And but certainly if it hit you on the head, you would know you've been hit by something.
I think we have a slide taken by an amateur astronomer again of what a meteor looks like as it's crossing the sky. It's a beautiful picture because it shows star trails, but also it shows that amateur astronomers can very easily take pictures of meteor showers, can't they?
Well, they can. Well, I have to admit, sometimes it costs a lot of film in order to record a meteor, but here we have one. What's happened is someone's gone out with their camera. They have pointed at one position in the sky. And of course, our Earth is rotating, and because the Earth is slowly turning, the light from the stars trail, and we get these star trails, and this is a couple of hours exposure. But we notice there's one streak of light that's going a little bit different than those star trails, and that is a meteor. And that is actually a Perseid meteor, a kind of a meteor we observe in August associated with a meteor shower known as the Perseids. This August 12th that's coming up, in fact, we're going to have the Perseid meteor shower.
Well, what does it mean that a lot of meteors? Like, is it something to worry about, a meteor shower?
Oh, nothing to worry about. It's just a beautiful sight to go out and have a look at. Each year, there are something like about 10 to 12 major meteor showers when the Earth is passing through the debris or garbage left behind by a comet. And as the Earth passes through it, this material falls down through the atmosphere, and we suddenly have a meteor shower. And around August 12th, and for a couple of days on either side, we have the Perseid meteor shower taking place. And these are meteors that appear to come from the constellation of Perseus. The best time to look for these meteors is after midnight. And in the case of the Perseids, a person should look over to the northeastern part of the sky just after midnight. You don't need telescopes, you don't need binoculars, just go out, look up into the sky with your eyes, have a nice comfortable chair, maybe a blanket to keep warm, get a little bit cool, and just watch for meteors.
Well, maybe we can look at the next slide quickly. We're running a bit short on time, but it's of a comet. Why did you choose to bring a comet picture tonight?
Well, I brought along a picture of a comet because the Perseids are associated with a comet. And the particular comet they're associated with is one known as Comet Swift-Tuttle, which was observed in 1861. This comet is one that has a 120-year period. Now, 1861 plus 120 years gives you 1981. And it's quite possible that the main body of this comet may be visible this summer or maybe next year. within a couple of years, that comet should be visible. This particular picture that we're looking at is a picture of Comet West, which was visible in 1976. A very, very beautiful comet. In fact, the last bright comet that was visible from the northern hemisphere. And a very nice naked eye object. We can see its tail. The tail could be tens of millions of kilometers long. A comet itself is basically just a big ball of ice and snow.
Oh, and that's a picture you took, we must say.
Yeah, that's a picture I took.
Of Comet West. There are two other type of astronomical events that are happening in July. One has already happened, and maybe we can go to the slides quickly. We'll show pictures of an eclipse of the moon, which you and I saw just the other night. Two weeks ago, on July 16th, 17th, we saw it. Here's a picture of the full moon. If we can go to the next slide quickly, we'll be able to see that, there's a bite taken out of the moon.
A bite taken. The moon is starting to move through the Earth's shadow, and in particular the inner shadow, what we call the umbra. And as the moon is slowly moving across the sky, it enters the Earth's shadow. And we can see it going along. And as we go, perhaps maybe the next slide, we can see that the eclipse has progressed a great deal. More and more of the moon is in darkness. It's a fascinating sight to be seen. We realize this is at full moon this is taking place.
It was right at midnight when we saw this, and if you look at the next slide, we see that at maximum eclipse, we see that, well, this is a bit overexposed, but everything's looking a bit red.
Yeah, just a little reddish tinge in there. We can just sort of look, if we look in the dark here, we can just maybe pick out some of the seas or craters on the moon. But this is just a little bit before, I guess, mid-eclipse. You've got about half of the moon, which is in darkness. And from beginning to end, this eclipse lasts a little over 5 hours, about 5 hours, 23 minutes.
And here's the eclipse moving out.
Here's the eclipse moving out, and there we're pretty well at the tail end of the eclipse. A very interesting sight. The last lunar eclipse visible from Toronto was 1979. And next year, next July, we're going to have a total lunar eclipse visible from Toronto.
Well, the last slide that we have tonight is rather interesting. As a coincidence, this show is to be broadcast for the first time July 30th, which is a Thursday. And just a few hours after the show is broadcast, several hundred people will experience a total eclipse of the sun in Siberia. And this is what the eclipse of the sun looked like from Africa last year. The next one is tonight, if it's July 30th. And if any of you have time, I guess you can run off to Siberia.
If you can quickly make your way and get your tickets, you can see a total eclipse of the sun. Usually when we have a lunar eclipse, there's often very soon after, or closely around that time, is also a solar eclipse.
Thanks very much, Ian, for coming by today. It's fascinating. There's so much going on.
Oh, there's a lot of things going on. I just hope people get out and look at the sky. Thanks, Randy.
Well, thanks again for joining us here at Astronomy Toronto. As you say, Astronomy Toronto is a news magazine on astronomical topics the last Thursday of every month at 8 o'clock. Next month, we'll be taking a trip to the DDO, hopefully, maybe see what's going on up there. And then in September, we hope to have a live phone-in where some of you out there can phone us and ask us questions on astronomical topics that you've been wondering out. So thanks again for joining us. We'll be seeing you soon. My name is Randy Attwood for Astronomy Toronto. Bye for now.